First, let's have brief review for type 1 errors and type 2 errors. In order to do a significant test, we first come up with a null hypothesis H0 and an alternative hypothesis H1. We do this on a population of questions. We take a sample from that population and we calculate a statistic that we call it p-value. If p-value less than significant level or alpha, we reject our null hypothesis. If our p-value is greater than alpha, we fail to reject null hypothesis. We might be wrong in either of these scenarios, and that's where these errors type 1 and type 2 come into play. There is a reality up here. There is a two possible scenario in reality. One is a null hypothesis is true. And the other is null hypothesis is false. Based on a significant test, we must two things to do. We might reject a null hypothesis or we might fail to reject. In a scenario where the null hypothesis is true, but we reject, that feels like an error, that we call it error type 1 or false positive. Also, if your null hypothesis is false and you fail to reject, that's a type 2 error or false negative. The other conditions are correct. If we increase the sample size, we can reduce the type 2 errors or false negative. Okay, let's back to our question. The predicted alpha value the first time is 0.02. But the researchers find p-value is 0.05. So p-value more than alpha and false negative. We can say it is false negative. So it is a type 2 error. And the second research, the predicted p-value is 0.05, but the researchers find p-value is 0.8. So this time p-value is too much more than alpha, fail to reject, false negative, and type 2 errors the second time is so much greater than the first time. So For decreasing type 2 errors, we have a increased type 2 error in the second research. We have to increase our population, and the answer is option C. Our sample size is not enough.